In physics today we're going to start a new topic which is called light. So light rays, they travel in a straight line from the source. So the light rays, they travel in a straight line from the source and they do not bend around the corner. And this is the reason why we are able to see objects. And the reason why we are able to see objects is because light travels in a straight line. So let us assume that this is the sun. This is the sun here. So the light that is coming from the sun, it will travel in straight line. So this, we can draw the direction of the light rays. So these, they travel in a straight line and they don't bend around the corner. So the light rays, they cannot bend around the corner, and that's the reason why we are able to see the objects. Then the next thing that we're going to talk about are the shadows. So a shadow is formed when light rays, they strike an opaque object. So shadows, these are areas that are formed when light rays strike an opaque objects. So for example, if light is moving in this direction and when it reaches an opaque object, so as it is traveling, when it reaches an opaque object, it's going to form a shadow. And that's the definition of the shadow. This is the area that is created when the light rays, they strike opaque objects. And these opaque objects are objects that don't allow light to pass through them. And examples of opaque objects, we have a house, a person, and a ball. Those are just some few examples of opaque objects. Then the shadows are referred to as the areas of darkness. So these are the areas of darkness. But sometimes, not sometimes, but light passes through some objects, and these objects that allow light to pass through them, they are referred to as the transparent objects. So I've said that shadows are formed when light strike opaque objects, and these opaque objects are objects that don't allow light to pass through them. And examples of opaque objects, I've said a person, a house, and a ball. Then the next thing that we're going to look at are objects that allow light to pass through them, and these objects are referred to as the transparent objects. So the objects that allow light to pass through them are referred to as the transparent objects. So these guys, they do allow light to pass through them. And examples, an example of a transparent object is glass. And the next thing that we're going to look at are objects that allow some light to pass through them. So they just allow some light to pass through them, and these objects are referred to as the translucent objects. So the translucent So these objects, they allow some light to pass through them. These are referred to as the translucent objects. I hope it's clear on shadows, but where you have questions, you can ask in the group. And the next thing that we're going to look at are the two types of shadows. So there are two types of shadows. We have the umbra and the penumbra. So we have two types of shadows. We have umbra. Let me just write that down. Umbra and penumbra. So we are going to start with umbra. So umbra is a type of shadow that is formed where light does not fall. So umbra is a type of shadow that is formed where light does not fall. That's umbra, and the umbra are referred to as sharp shadows. And how this umbra is formed, the umbra shadows is formed where light comes from a small source. As they come from the small source, they are going to hit an opaque object. So I've said an umbra is a type of shadow that is formed where light does not fall. So where light does not fall, and these are referred to as sharp shadows. Then the other thing that you must know about the umbra is that they are formed from a small source of light. So small source of light. Let us now look at how the umbra is formed by drawing the diagram. So for example, this is a small source of light. Then we have our opaque object here, and we have this surface. So light will move to the opaque object, so this is a small source of light, small source of light. Then here we have our opaque object, and this is just the surface to reflect the this is the surface that will just show the shadow. So just this surface, and the shadow that is going to be formed is this type of a shadow, and this shadow is referred to as the umbra. So the umbra is the type of shadow that is formed where light comes from a small source. So as it comes from the small source here, it's going to strike the opaque object, and the opaque object here is going to form a shadow which is referred to as the umbra. So this is also referred to as a sharp shadow. Let us look at penumbra. So the next thing that we're going to look at is penumbra. So penumbra is a type of shadow that is formed where some light falls. So it's a type of shadow that is formed where some light falls, and this type of shadow is referred to as a partial shadow. So the penumbra is also referred to as the partial shadow. Then the penumbra is formed where light comes from a brighter source. So the penumbra is formed where light comes from the brighter source. So I've said this is a type of shadow that is formed where some light falls. So where some light falls. Then the other thing that you must know that these are types, or these are partial shadows. Then they are formed where light comes from a broader source. Let us look at how these are formed. So here I have a broader source of light. So I have a broader source. Then here we have an opaque object, and this just shows the surface that is going to display the shadow. So as light comes from the broader source here, it will strike the opaque object, and our face shadow here is going to be formed. So we have this face shadow, this part. So this will be the dark shadow. Then our next shadow, as light falls, it's also going to be formed. So this shadow that is formed, that has some dot where some light falls, this is referred to as penumbra. And this type of shadow is referred to as umbra. So that's all about the penumbra and the umbra. Where there are some questions, you can ask in the group. The next thing that we're going to look at is refraction. So refraction of light is the next thing that we're going to look at. So refraction is defined as the bouncing back of light. So the main reason why we are able to see objects is because light is refracted into our eyes. And when light is refracted into our eyes, we are able to see objects, we are able to see houses, we are able to see all these different kind of things. You're able to see the television, you're able to see the refrigerator, you're able to see a lot of things, and this is because of refraction. And the other thing that we're going to talk about on refraction is how refraction looks like. So I've said refraction is just the bouncing back of light. So this is the bouncing back of light, and let us look at how refraction looks like. So for example, this is a refracting surface, and this refracting surface can be a mirror, and we have this line. So this line is referred to as, okay, I'm going to label it first. Then we have this line, we have the other line here, we have this direction in that direction, we have an angle here, we have another angle here. Let us now look at the parts. So the ray that strikes the refracting surface of the mirror, this is referred to as the incident. This is referred to as the incident ray. Then the ray that is drawn 90 degrees to the refracting surface, this line that is straight, is referred to as the normal. Then the ray that leaves the refracting surface, or that strikes the refracting surface, is referred to as the refracted ray. Then we have angles here, so I can represent them by I and R. So here I stands for angle of incidence. It is referred to as angle of incidence. So this is angle of incidence. Then the R is referred to as the angle of refraction. So angle of refraction. So I've said that the incident ray is the ray that strikes the refracting surface. The refracted ray is the ray that leaves the refracting surface. Then we also have the normal. So the normal is the line that is drawn 90 degrees to the refracting surface. Then we have the angle of incidence here, which is represented by I. So the angle of incidence is the angle that is between the normal and the incident ray. As you can see, it's in between the incident ray and the normal. Then the angle of refraction is the angle that is between the refracted ray and the normal. So that's how refraction looks like. Let us look at the law of refraction. So the law of refraction. So this one usually comes in the exam. They're going to tell you, can you mention the law of refraction? So the first law of refraction is that the incident ray and the not the incident ray, sorry, the angle of incidence and the angle of refraction are always equal. So the angle here and the angle here, they are always equal. So I've said the angle of incident and the angle of refraction are always equal. So we can say I is equal to R. But when you're giving in the exam, make sure you write the whole statement. Then the other row on the row of refraction, we can say that the incident ray, the normal, and the angle of incidence, they always lay in the same plane. So as you can see here from this diagram, the incident ray, the normal, and the refracted ray are this side. We can say they are on the bottom part. So these always lay in the same plane. So sometimes you can draw them upwards, downwards, to the right side, to the left side. But you must know that the incident ray, the normal, and the refracted ray, they all lie in the same plane. So here you can say the incident ray, the normal, and the refracted ray they all lie in the same plane. They all lie in the same plane. So these are the main 2 points that you need to know. And now let us look at the next thing. So the next thing that we're going to look at on refraction is are the two types of refraction. So we have two types of refraction, and this is regular refraction and irregular refraction. So there are two types. So I've said the types of refraction. So types of refraction. So I've said there are two types. There is a regular and irregular. So irregular is also referred to as diffuse refraction. So in some books you're going to find that they're going to just write two types of refraction as regular refraction and diffuse refraction. They may not write irregular refraction, but you must know that irregular refraction is also referred to as diffuse refraction. So what is regular refraction? So regular refraction is a type of refraction that comes from smooth surfaces. So this comes from smooth surfaces. Smooth surfaces. Then what about irregular or diffuse refraction? So this is the type of refraction that is formed from irregular, from rough surfaces. Sorry. So this is a type of refraction that is formed from rough surfaces or surfaces that are not smooth. So rough surfaces. Let us now look at the images that are formed by the mirror. So there are some properties that you need to know there are some properties that you need to know that are formed by the mirror. So for example, we have the mirror here, and the image that is produced by the mirror, first thing, it is virtual, and this means that it is not real. So not real. And what virtual means is that it's a type of image where light does not reach a certain surface. For example, if you look yourself into the mirror, it actually shows that the light is coming from the mirror, then it is going into your eyes, but that's not real. The real thing is that the light strikes the mirror, then from the mirror the light is going to go into your eyes. That's why you're able to see yourself into the mirror. It's not like the mirror. It's not like the light is coming behind the mirror. So that is what virtual means. So virtual means not real. So the other property of the image that is formed by the mirror is that the image is inverted. This means that the right and the left are opposite. So light and left are opposite. Then again here, the image has the same size as the object. So same size. Then the image is also upright. So these are some of the things that you need to know on refraction. Where you have questions, please ask in the group before we go any further, before we start having any complications. Thank you very much.